Okay, good afternoon everyone. Myself Daneshwari Nula. Okay, so with our last few classes, we have successfully completed with your module 1 and module 2. Okay, and thereby here I am coming across with module 3 here. Okay, so module 3 is all regarding your. Okay, I'll just give you a short overview of your module 3 there. Okay, sorry for a mistake here. I have written it as module 2. Okay, it is module 3, system modeling, and there are two chapters which you are coming across here. One is called out as system modeling, and one more is called out as implementation. Okay, so with respect to system modeling, you are coming across mainly with three different types of modelings there. Okay, so as and when my classes will go on, you will get across to know with those respective modeling there. So this is all regarding your design section. Then one more chapter which I said it is a combination of this module 3, that is implementation, where a real-time example of these things are being taken, the real-time use cases or the real-time case studies are taken and are being implemented. Okay, so your module 3 involves across with these respective outcomes ultimately. Okay, at the end of this module 3, you will come across to know the analyzing of the importance of establishing the boundaries of a system model and its context. Okay, then you will be in a position to express the concept of behavioral modeling, data modeling, object modeling. What do you mean by them? Okay, apply, then you will be in a position to apply some of the notations defined in UML that you have studied in your second module. Okay, and these notations may be used to develop system models there. Okay, then here even you will be in a position to define the principal tasks of the software project managers there. Then analyze the need for project planning in all the respective software projects there. So these are the set of module level outcomes which are being expected by your module 3, that's your system modeling. Okay, these are your respective four different models which are coming across here. One is called out as context model, the second one is called out as interaction model, then third one is structural model, then comes is your behavioral models there. Okay, so these are respective models there. Apart from this, as a whole combination, if I am speaking about a system, so I call it across as a system model there. Okay, so here let us come across with the very first one, that is what do you mean by system modeling. Okay, so system modeling, always keep in mind, system modeling is nothing but it's a process of developing abstract models of a respective system, with each model presenting a different view or perspective of that particular system. Okay, so wherein it is abstract models are nothing but wherein you are just generically you are just giving across with an rough sketch about your respective model of a system. Okay, in such a way that with each model presenting a different view or perspective of that particular system there. Okay, so you are having a different presentation or a different view about that particular modeling there. Then comes system modeling has now come to mean representing a system using some kind of graphical notation there. Okay, which is now almost always based on notations in UML. Okay, so ultimately a system modeling goes in and around with the notations which we are using across with an unified modeling language there. Okay, then the third one is wherein to know more about your system modeling is system modeling helps the analyst to understand the functionality of the system, and models are used to communicate with customers. Okay, system modeling helps to analyst. Okay, that is, it helps the analyzer to understand the functionality of a respective system there, and models are used to communicate with the respective customers there. So this is with respect to your system modeling there. Then here comes across with what are your existing and planned system models there. Okay, so ultimately in our last classes we have come across to know how important is a respective model there. Model of the existing system are used during requirements engineering. They help clarify what the existing system does and can be used as a basis for discussing its strength and weakness there. Okay, these then lead to requirements for a new respective system. Okay, then one more comes across as models of the new system are used during requirements engineering to help explain the proposed requirements to other system stakeholders there. Okay, engineers use these models to discuss design proposals and to document the system for implementation. Ultimately we have come across to know that how models are very much important in order before you are implementing it, and model is necessary because we know very well that any changes can be done to a respective model and that later will directly affect the implementation there. So that's why ultimately you will be looking across with the existing model which is already there, then you look across with your respective planned system model there. Okay, then So whenever I am speaking about the system perspective is nothing but, if at all I am speaking about a system, so what are the perspective which you will be looking across? Okay, the perspective lies across in 4 different categorization as it has been discussed here. One is called out as an external perspective, the second one is called out as interaction perspective, the third one is structural perspective, and the fourth one is behavioral perspective. Okay, external perspective is nothing but where you are modeling the respective context or the environment of the system where it will be running. So those all things are called out as your respective external perspective there. What do you mean by interaction perspective? Interaction perspectives are nothing but interactions between the system and its environment, or else it can be the interactions which are happening across the components of a respective system. Okay, then the third one is structural perspective, where it says structural perspectives are nothing but where you model the organization of a respective system or the structure of the data that is processed by the system there. Okay, so that is structural, where where you model the organization of a system or the structure of that particular data that is processed by the system there. Okay, then comes the fourth one, which is with behavioral perspective, where you model the dynamic behavior of the respective system and how it responds to events there. Okay, behavioral perspective says across with how do you model the changes which are happening across with the system and how it responds to that particular event. Okay, those all things are respective. These all, I can just say that these are your 4 perspectives which will help you to decide regarding the particular system with what you are working there. Okay, this is one. Then there are different UML diagrams which I have discussed even in my prior classes also. That's in your second module also. I had spoke to you regarding these UML diagrams there. There you had come across with 3 different types of model, if you remember. One is class model, the second one is state model, and the third one is interaction model. Okay, with these 3 different types of models which define the system perspective, I have different diagrams which are supporting these models there. Okay, so those things are called out as activity diagrams, use case diagrams, sequence diagrams, class diagrams, and state diagrams. Okay, individually, if you just go, it is self-descriptory, and slide which will tell you that what do you mean by an activity diagram. Activity diagram is which shows you, okay, activity diagram shows you with the activities involved in the process or data processing. Okay, then what is use case diagram? It shows the interaction between a respective system and its environment. Okay, what is sequence diagrams? It shows the interactions between the actors and the system, okay, and between the system components. Okay, that's with your sequence diagrams. Okay, so one by one we'll come across in this particular module, we'll come across to know or else examples for all of these diagrams in detail. Okay, keep in mind we have successfully completed with your software design activities, that is software engineering activities. We have successfully completed with the first one, that is requirements collection and analysis, and now we are with design. Okay, in design, firstly we have got across to know what are models, what are the different types of models and other things. With each of the model, what are the diagrams which will give you and justified outputs there. Okay, then comes class diagrams. We have come across with good enough examples on class diagrams. Okay, which shows now you are in a position to explain what do you mean by object, what do you mean by classes, what do you mean by associations between the classes and other things. Okay, what are state diagrams? State diagram shows how the system reacts to internal and external events. Okay, so ultimately state diagrams are not drawn for all the class diagrams there. Okay, all the system compositions there, wherein it is being included for only the things which are complicated one or else a complex one. Okay, that's with your UML diagram types. Okay, even we are using across with your graphical models, okay, as a means for facilitating the discussion about it can be an existing one or else a proposed system. Okay, so ultimately why is the need of this graphical model? Okay, so that any incomplete and incorrect models are okay, as their role is a support discussion. Okay, now as I have used this annotation, okay, it is something like if I want to draw out something, I'll just use it and I start explaining you, so it becomes quite easy for me. Okay, else it is the same one if I start explaining you in terms of a textual matter more, so ultimately it becomes little bit tough to have an implementation down for that. Okay, so that's why that is the use of the graphical model there as a way of documenting an existing system there. Okay, so ultimately that's a second best example or else a use of graphical model. Okay, one is it facilitates discussion. Okay, because to have facilitation in the discussion I use graphical models. Then for documenting an existing system. Okay, so how can I have the document being created for my existing system? I can make use of this graphical model. Else a detailed system description, okay, that can be used to generate a system implementation. Okay, so you can have a detailed system description also by using a graphical model. Okay, you can get it like as I said you, your design is divided into two types. One is system design, one more is class design. Class design is a detailed design, so you will be getting a detailed description of the system what we are looking across. Okay, so next let's come across with the very first model, and that is context model. Okay, so what is this context model? Context models are used to illustrate, usually it is illustration of the operational context of a system. They show what lies outside the system boundaries. Okay, so that is what are being related across with the social things, social concerns, what are organizational concerns, okay, which might affect any kind of a decision whatever has been taken. Okay, where we can position the respective system, or else what is the boundary for our respective system. These all things can be identified well by your context model. Okay, then comes architectural model. It shows how the system, it shows the system and its relationship with other system there. That's with your architectural model there. Okay, so now when I am used here with a sentence called out as, with a statement called out as system boundaries. Okay, what do you mean by the system boundaries? Okay, system boundaries are established to define what is inside and what is outside the respective system. Okay, they show other systems that are used or depend on the system being developed there. Okay, that's a very first thing. Okay, now I should know the boundary under which I'll be working there. Okay, I should know what lies inside and what lies outside my respective system there. Okay, then the position of the system boundary has a profound effect on the system requirements. Okay, that's the second one. Then comes the third one. Defining a system boundary is a political judgment. Okay, now whenever I am defining a particular system boundary there, so it happens to be influenced or is pressurized. It can be looked across by the political judgments there. Okay, that's the third one which can let you tell regarding the system boundaries there. Okay, then comes whenever I say context model, then what can be the context model for a one case study which I have taken, that's called out as Ment system. Okay, so whenever I say Ment system, so here you can just say that I say this Ment system can be divided further into sub models or else subsystems there. What are those subsystems? One, I can have it as patient record system. In my last classes also I had said you Ment system is nothing but some, in simple way you can call it as an hospital management there. Okay, one is patient record system. The second one is who are admitted, who are non-admitted, admission system, prescription system, appointment system, then HC, that is you are getting to know with the statistics of your respective considerations. Okay, how many number of times a concern has happened and all those things. Then comes management reporting system. So these are all your different respective subsystems, okay, which are included in this main system called as Ment. Okay, so this is an context of the Ment system there. Okay, so if at all I want to consider further with what are the process perspective for each of them. Okay, so I have to decide with individually. I have to say that what is patient record system, what is admission system, what it includes. Okay, what is prescription system, what it includes, what is appointment, what is HC statistic system. Okay, what are the functionalities for each of them. So for that I call it as the process perspective there. Okay, so individually I will be defining across with the processes for each of them. Okay, so that I will tell you in the next class. Okay, for time being just get to know that this is an introduction for your third module there. Thank you.